morning, students. Now we want to go for a recap. Okay, so regarding the Unit 3, so for better understanding and quickly see the overview of the what the content has been covered under Unit 3. What is machine learning? It is a subset of artificial intelligence that enables the system to learn from the data. That is very, very important. So, it is a subset of the artificial intelligence that enables the system to learn from the data. Instead of being explicitly programmed for a task, machine learning algorithms use statistical techniques to allow computers to improve their performance based on the data, experience data. So, what is machine learning algorithm? Machine learning algorithms are mathematical procedures or set of rules used to analyze the data. Okay, so the mathematical procedure to use to analyze the data. So, for example, we have machine learning algorithms like we'll see actually one by one. Okay, so the key concepts in machine learning is data, labeled data, unlabeled data. So we should know the difference between what is labeled data and unlabeled data. Includes both the input and output, correct output. Unlabeled data only inputs without outputs, and a mathematical representation, yeah, that makes prediction or decision based on the model data. Training, so we have a training. 80% of the data will be used for training and 20% will be used for the testing. So the algorithm is a set of rules or instructions used by the model to learn from the data. So we have linear regression, decision tree, neural networks, and k-means. Okay, and then prediction. The once it has been trained, a model can be predict output for a new or unseen data. And last one is evaluation. Okay, and validation. So when you have evaluation and validation, we have different techniques which have been used for regression models or classification models. We have a different category for evaluation, for root mean square, r square, that is for a regression model. For classification model, we have accuracy, precision, recall, F1 score, harmonic mean of recall and things. Okay, so this we have seen in the class. We already have saw in the previous lecture. Okay, coming to the recall and F1 square thing is a true positive or true negative, which I already discussed in the thing, right? So when you have a supervised learning and unsupervised learning, what is the difference between these two that we supposed to know? So the supervised learning, the labels have been, I mean the input and output are correlated. Unsupervised learning, okay, there is a lag. When we don't have a relation between the variables of independent and dependent variable. Okay, so learns from the unlabeled data. So the example is customer segmentation or topic modeling is for unsupervised learning, where supervised learning we learn from the labeled data. Okay, so a semi-supervised learning and reinforcement learning. Okay, these are all the machine learning techniques. Okay, and coming to the application of machine learning, so we also use in healthcare, finance, retail, manufacturing, and transportation. So common machine learning workflow, the problem definition, data collection, data pre-processing, model selection, training the model, evaluating the model, hyperparameter tuning, deployment, monitoring, and upgrade. So machine learning algorithm follows this thing. Okay. So I thought of giving an example with a realistic example starting from the problem definition, data collection, data pre-processing, how the model has been validated and evaluated. Okay, how the data has been splitted. Okay, whether which type of model evaluation technique has been used. Okay, leave one out class validation or k-fold or train test method. That regarding that part, I just thought of giving one real example starting from the how to do a machine learning part, okay, for the chemical engineering. So I am planning for that. It may take some few minutes, few time, few I mean a time period. I mean it may take some time actually for prepare that one. Okay, it's not readily available. Okay, for I need to tune tailor to the chemical engineering perspective. Okay, so that I will do from my part. Okay, so the challenges in machine learning is overfitting, underfitting, bias variance trade-off, and data quality and quantity and interpretability, which we have already discussed in a very extensive way. And coming to the algorithm, we have a linear regression, logistic regression, decision tree, random forest, support vector machine, name Bayes. Okay, so these are the algorithms which are available. Okay, so then we will go for a classification and statistical method, like what you call classification or classification methods. Okay, so linear regression or logistic regression, when we need to go for, and what is the description which has been mentioned over here, and application of fault detection in the distillation column. Okay, is an example for support vector machine. So most of the cases, okay, in the support vector machine or what you call random forest is mainly used. Okay, so the support vector machine is used for a classification. Okay, decision tree for classification as well as regression. Okay, so hope you understood this. When we need to go for which method type of algorithm, that is very important. So the support vector machine excellent for classification task. Okay, normal versus faulty. Is then effective in high dimensional spaces, especially when features are engineered from sensor data, work well with limited and labeled data set, which is common in industrial diagnostics. And a random forest example, okay, application is predicting the product yield in a chemical reactor. So in a reactor design or process optimization task, engineers want to predict the yield of the product based on the operating conditions, operating parameters like temperature, pressure, catalyst concentration, feed flow rate, and the reaction type. Why random forest? When we have a non-linear relationship, then we go for a random forest between the input and the yield. It provides future importance, helping engineers understand which factors most influence the yield. It is also robust to noise and overfitting, especially when data is limited or measurement errors. Okay, example is a historical paint data. Random forest model can be trained to predict the product yield. So I will show one example for this algorithm. Okay, how it has been written for a real chemical engineering perspective, and that will help you to understand this type of algorithms. Okay, and then later how to evaluate and validate the model. Okay, using different techniques. Okay, so coming to the algorithm types. Okay, so you have a k-mean clustering. Okay, so unsupervised learning algorithms like k-mean clustering, hierarchical clustering, principal component analysis, um, density DB scan. Okay, facial contribution, artificial neural network. Okay, so these are the things actually. So when you see the DB scan type. Okay, so we have different types which we have given the examples for that particular types. Okay, so hope you would have understood during that particular lecture. So if you have any doubt on this, okay, just come and knock me on the unit 3, either any of the part. Okay, so we will better understand. I just quickly would like to go to this type of a particular material. Okay, to quickly understand the overall view of the unit 3. So you have a linear regression, logistic regression, decision tree, random forest, support vector machine, kern nearest neighbors, okay, and then naive Bayes. Where when we need to use for this case, k nearest the neighbors and the naive Bayes. So the pattern recognition where the classifies based on the closest training examples. Okay, and then naive Bayes is mainly used for test classification, probabilistic classifier based on Bayes theorem. Okay, so I'm not getting into this particular Bayes theorem part. Okay, if you want to explore on this particular thing, please in face-to-face section we will discuss about this type of algorithms. Okay, mainly naive Bayes and k-needs neighbors, which has not been extensively discussed during our lecture. So this linear regression y is equal to mx plus c form. Okay, that you know already. Linear regression is very simple, and logistic regression we have a yes or no type, decision tree, we have what you call the dendrogram, which we have been explained. Okay, so if you see if the boiling point is greater than 30%, go for this case. If it is less than, then go for this one. If the components are immiscible, go for extraction. So it's a decision. It's like a flow chart type. Is a flow chart. It's not a dendrogram. It's a flow chart type. Okay. So for diagnosis in a process plant, a pressure drop or open valve, okay, it may lead, will give you a leak, or temperature rise and close valve may indicate the blockage. So these are the examples which we have seen in the things. So what I'm trying to say is that hope you understood the recap of the first two lectures which has been discussed in the unit 3. Okay, so if you have any doubt, you just get back to me, and I just would like to put another 10 minutes video on the recap of the third and fourth part. Okay, so with this thing, I just stop it here. If you have any doubt on the recap also, you just come and knock me. The recap is mainly to understand the overall unit, that is a third unit. Okay, with this note, I just stop it here. Okay, thank you for listening.